Hello everyone, my name is Alan from Ikomia, and today we'll see how you can train a YOLOv9 model on your custom dataset. First, we will quickly take a look at the official GitHub repository, and then we will see the step-by-step process on fine-tuning your model using a Colab notebook. Let's check out the official YOLOv9 repository. If we go down a little bit, we can see the performance comparison on the MS Coco Object Detection dataset. So we see the two new release models, which are YOLOv9 and Gelan. And what stands out is that YOLOv9 is the current state-of-the-art object detection model. And if we compare with YOLOv8, it's interesting to see that with similar performance, the YOLOv9 model is much smaller. And let's check out the different sizes, which are the S, M, C, and E. In this tutorial, I will use the YOLOv9 C version, which is a good compromise between the precision and the model size. Now let's get into the fun part by jumping straight into the training notebook. First, let's check out our runtime, make sure that we are using GPU. So by changing runtime, and this is correctly selected, you can validate that we are using T4 GPU by running the following commands. And then the only dependence that you have to install will be Ikomia. We pip install Ikomia, so I will run it now. Here we can see that we have 15 gigabytes of GPU. During the installation process, we can check out the dataset we'll be using. It will be the basketball player dataset. Looking at an image, we have the labels for the players, the ball, referees, number of points, the period, and times. Going back to the Colab, so it looks like it's installed. We just have to restart the session. So the next step is to download the dataset. So directly from RoboFlow. If we refresh, we can see that we have the three folders, test train and the validation dataset. Now that we have our dataset, we are ready to create our training workflow. So the first step is to initialize it. Then we load the dataset with the dataset Coco algorithm. And we add the Train YOLOv9 algorithm to the workflow. We can set different parameters like the model name, the number of epochs, batch size, train and test image sizes, and also the split ratio between the train dataset and the test dataset. Let's run this workflow. Here I'm missing a comma. It will download all the necessary algorithm like dataset Coco and Train YOLOv9 and install all the necessary packages. So it might take a few minutes for the first run. So the installation took about 5 minutes, and now the training is starting with the first epoch. So we will be back at the end of the training. All right, so the model has done training after 45 minutes, and the model weights are saved into this folder. You can see the metrics for the different classes. It's close or above 0.9 for the different classes, which is pretty good. For more information about the metrics over time, we can check the graphs. So they will be under the save directory and results. So we have the losses for the train and the validation. Also, we have the metrics for the precision and recall. We can see that we are almost reaching a plateau. We could maybe have better fine-tune our model with a bit more epochs, but this is definitely good enough for this example. Now we can test our model. So by running inference, first, so we have to set the output folder name. So we copy this one. Then we create the inference workflow. So by initializing, adding the infer YOLOv9 task, and setting the parameters. So by default, the algorithm infer YOLOv9 will use the pre-trained Coco model, and we will test that first, and then we'll use our custom train model. So let's run the workflow. So here we just added the task, and now we have to run on the image. Let's run this cell as well. And here we have the results of the pre-trained Coco model with only the class person which is detected. So now let's try out our fine-tuned model. And we will uncomment the parameters. And let's run the workflow again. And here is the output of our custom model. You can see that it detected the player, the referees, the hoop, and the scoreboard. Maybe you can't see the scoreboard, and here this is better. So this is the end of this tutorial. I hope you enjoyed this video, and I will see you in the next one.